All right, so chapter 3, we dive into the meat and potatoes of economics. We are going to talk about the diagrammatic representation of reality that we're going to be using over and over again. We're going to talk about it in a more zoomed out perspective this time. We're going to talk about markets. And then as we get more and more specific, right, this is microeconomics, so that means we're going to focus and get closer and closer into things. We're going to be talking about how the influence of the market dynamics impact individual firms. But before we get there, let's all get on the same page in terms of what the heck we're talking about. So when we're talking about demand in economics, right, economics is very jargony, so just like when you learn pool or any kind of sport, right, like a bumper on a pool table means something very different than a bumper of your car. Right? A cue for a pool cue means something very different than a cue for a visual cue or for a theater cue or something like that, right? So similarly, demand is not saying I need this, give this to me now. It's not somebody throwing a temper tantrum. It is the amount of some good or service that consumers are firstly willing, they have a desire to purchase it, and able to purchase it. And this is going to be at each, or the other way we can think about it is at each or at a given price. And the price we know is just what you actually pay, right? You go to the store, DVD costs $10, the price of it is $10. Now, we need to differentiate between demand and quantity demanded. The demand is the one that's at each price, right? Each or given price. So demand is telling us the overall schedule. The quantity demanded is kind of a sub-definition of demand. And we represent it like this: quantity demanded and this is defined as the total number of goods and services that are consumed at a given price. So if I told you that the quantity demanded was $400,000, the next question would be, at what price? What price is that quantity demanded related for? If I were to tell you that demand had increased, that would be me talking about at any price. At any price, people are wanting more of that particular good or service. Questions on the distinction between quantity demanded and demand. It's going to be one of those things that you conflate constantly in this class until you don't. You just got to make those mistakes and learn the hard way. All right, let's put this in a graph format, right? This is a diagrammatic representation of reality. Let's actually put it on a diagram. So we're just going to be talking about the first part of the Cartesian coordinate plane, right? You guys remember math and algebra and all that kind of stuff? All right, this is our Cartesian coordinate plane. We're just going to be focusing on this part over here, right? And the reason why we're only focusing on this part is because this is the only part with positive numbers on both axes, right? If we go to any other of the parts of the Cartesian coordinate plane, we end up having negatives, and negatives don't make a heck of a lot of sense when we're talking about economics, right? When was the last time you had a negative price for something? Never. When was the last time there was a negative amount of stuff purchased? Never, right? So we only deal in the positive numbers here, so we just omit the rest of the Cartesian coordinate plane and stick to that first quadrant there. Now, what are we going to label our axes? What are we going to label our axes? Well, on the y-axis, we are going to label that our price. On the y-axis, it's going to be labeled our price. On the x-axis, we're going to label this as quantity. And I want to address the elephant in the room. For those of you that have a little bit of mathematical inclination, you might be saying, well, wait a second. In a traditional Cartesian coordinate plane system, right, we would have something like x on the x-axis, right? And then we would have something that's f of x on the y-axis, right? Maybe it's f of x equals 2x or something like that, right? And it goes up like this. So the situation that's happening here is reversed. So here we're putting the f of x on the x-axis and the x up on the y-axis. Now, what do I mean by that? Well, how do consumers actually make consumption decisions? They make them based on price, right? They don't make them based on the quantity that everybody else is consuming. That doesn't make any sense, right? They make them based on the price. And so this price, for all intents and purposes, right, this is our x variable. And this quantity here is our function of that x. So things are a little bit reversed here, which is part of the reason why it's very easy to flip these things around, right? Do some left-right dyslexia. So as a way to get around that, I've developed a few different mnemonics. The one that I've developed for this is to use the alphabet, right? This P comes before this Q in the alphabet, right? If you sing the alphabet song to yourself, A, B, C, D, E, F, G, H, I, J, K, L, M, N, O, P, Q, right? The P comes before the Q. So similar to the alphabet, your price comes before the quantity when you are labeling the graphs from left to right. Does that make sense, the mnemonic? I don't know how many years ago, but at some point I was talking to some student in office hours and they were like, I had no idea what you were doing the whole time when you just said LMNOP, and I was like, oh really, I have to sing the whole alphabet song. Okay, good to know. So just making sure you sing the whole alphabet song, you get to the LMNOP part, PQ, P comes before Q, put the price on the left axis, quantity to the right of that. Does that make sense, everyone? All right, cool. Now, how are we actually going to graph our demand curve? We're going to graph our demand curve by essentially looking at different combinations, different bundles that people will consume, right? And so we're going to use gasoline as an example here. And, you know, if the price of gasoline shot up to, you know, $6.60 or something like that, right? Then, you know, there probably wouldn't be that many millions of gasoline consumed at that price, right? If this is our price, and this is in dollars per gallon, this is our quantity, this is going to be in millions of gallons. So this at $6.6 per gallon, you know, maybe there'd be 210 million gallons demanded in the United States. If the price went down to, you know, something still kind of expensive but not outrageous, at $4.4, you know, maybe we end up with something around 500. So on and so forth. So we observe demand by the fact that prices fluctuate over time, and at different prices, we're going to have different amounts of gasoline that are consumed. And so we end up with a demand curve that looks something like this, right? And this reflects our own experience when we are at the pump, when we are at the grocery store. Now, gasoline is a really interesting example because no other good that we have is so publicly advertised and available, right? It's in giant numbers as you go down the street. And so, strangely enough, we start to associate the price of gasoline with the health of our economy. Now, gasoline does have to do with a lot of stuff, right? Not only does it impact our discretionary income because it influences heating costs as well as transportation costs, it also impacts the costs of our goods and services that we get because it costs money to transport those goods and services, right? Also, it costs money to package those goods and services. Oftentimes, the packaging is in plastic, which is made of oil. So it really, you know, reverberates throughout our supply chain. That being said, it's still not the best metric for what's going on, because a lot of the fluctuations with gasoline don't necessarily have to do with demand. They have to do with supply, right? Which is the other half of this equation. So we're going to talk about that in a little bit. But right now we're talking about demand, we're talking about gasoline. One of the things we find is that this is a downward sloping line, right? It's got a slope of, let's see here, we can actually calculate the slope here. So it's got a fall between 4.4 and 3.8, so that's a 0.6 negative fall, and it's got a growth of 300 million gallons, and so we'd end up with a slope of the rise, or the lack of rise rather, the fall over the run, and so we would end up with, you know, some very small number, some very negative small number, something, let's see here, 0.00, oh, one too many zeros, 2. So demand always has to have a negative slope, because why? There is this thing called the law of demand that states that as prices increase, quantity demanded will decrease. The flip side of the law of demand, or the other part of it, is as the prices decrease, the quantity demanded increases. As things get cheaper, everything else constant, right? And that's one of the things that we're assuming throughout these economic models, right? This whole notion of ceteris paribus. Which is our notion, this is Latin for all else equal, or all else constant. And this is saying that, you know, when we're talking about the price changes and the quantity changes, right, there's no other moving factors. So we're not talking about unemployment, we're not talking about advances in gasoline efficiency in cars or anything like that, right? We're not talking about substitutes that might be there for gasoline-powered cars, so on and so forth. There are lots of things that could impact the demand, but right now, when we're talking about the law of demand, we're just talking about how the price increase results in a quantity decrease, or how a price decrease results in a quantity increase. We have to assume all of those other factors are held constant. Questions on demand, quantity demanded, and the law of demand? All right.